Okay, the barge contains 2 battery boxes, a control box in the center, and a pneumatic valve control box. So this is a controller, that's just a valve box.
Okay.
So what happens is he sends those commands. There's pneumatic solenoids in the control box that goes to each ballast control. Each ballast control consists of 3 valves, which is charge air and vent and water.
Okay.
So when you tell the unit to descend, the vent will open
Okay.
and the water valve will open. So as water comes into this port here, and there's a screen goes on that lower port. Right now the water hose barb is on it, so we can put water hose to
Oh
it.
yeah, I see it there. Yeah.
But there's a stainless steel screen filter goes on there to keep debris out. But it will go into a manifold that will go to all the valves. They're all linked together, and that will go to each tank. You tell it to flood. Now when it's auto balancing, it controls those individually to maintain balance. So water goes into all the ballast tanks and starts changing the gravity so the thing will go down.
Okay.
When you're ready to bring it up, same thing. The vent will close, the water will open, and the air will open. So as air gets pushed into these tanks through one of these ports, it's going to push the water out, and the water will go out the same port that it came in.
Okay, that makes sense.
Inside these tanks, this is air. This pipe goes in about midway of the tank, turns up 90 degrees, so water comes in, or air's at the top. This lower pipe goes in, turns 90 degrees, and goes to the bottom of the tank to pick all the water up off the bottom of the tank.
Okay.
There's a piece of copper in there for electrolysis and corrosion, and for anti-fouling. There is also off this mechanism that runs through there is a float sensor that runs top to bottom, and by reading that you can see what the water level in the tank is.
Yeah.
It gives a percentage,
Right.
and that's just a window of what's really in there, but it's not keen on exact, it's just a percentage.
Okay.
So you can see if it's operating correctly.
What would you say we're looking at? How much this weighs all in?
Okay, the frame itself weighed about 3,000 pounds.
Okay.
When everything got put on it, we couldn't weigh it anymore. But from the way we moved it around in the shop, I'm thinking we're running about 4,500.
Did you ever take it to like a certified scale and have it weighed? No. Okay. But you said you've had no issues with lifting it with two.
We lifted it with 2 fork trucks on either
forklifts.
side.
Yeah, on either. Okay.
And the little fork truck.
Little fork trucks,
Okay.
yeah.
Well, it'd be certainly light enough to transport anywhere.
Oh yeah, I mean it was designed to go on the back of a semi. It's well under the.
Oh yeah, yeah.
And it's pretty equally distributed weight, so they wouldn't have any issue front to back.
And it'd be easy to secure it as well. I see.
To strap it down.
Strap it down. Yeah, absolutely.
I mean,
Yeah, but that kind of weight.
There's anchors.
Yeah, I see them here. Yeah, yeah.
So I want to tell you about those. Also, there's one of those in each bottom corner.
Yes.
The requirements was it had to have mooring points on all 4 corners.
Of course.
Okay, it has 4 lifting eyes. You can see how this is made at this angle.
Yeah.
This needs to be lifted with a bridle.
With a what?
When you lift this, if you use a crane to lift it,
Yep.
you don't want a spreader bar bridle. This is very strong, but you don't want to put a lot of load to the center. So if you had a spreader bar, it'd pick it straight up.
Right. Okay.
This was when we had the frame.
When we transported it, so we transported it several times on a 30-foot flatbed trailer, just a regular trailer.
Pulling with a pickup truck.
With a pickup truck.
Yeah.
And what we did was we lifted it from both sides
Yeah.
and backed the trailer under it.
Oh, that's a good idea. Yeah.
Yeah, gooseneck trailer.
Yeah. Did you put these on these
This
on?
is just on the ground, just keep it off the grass.
Keep it, yeah.
Yeah, these just chunks.
Okay, perfect.
Those are not attached. So these are check valves here for the air in case something happens to a hose here as well.
Yep.
You don't lose.
Right.
And then this is the pressure relief valve in case this tank was for some reason get overpressure.
Very important.
And they're there.
Okay.
There's other check valves off that unit because that's a,
I see it there.
okay. What those are, when the valve exhausts, you have to have a vent for the manifolds to exhaust,
Okay.
and that tube runs up to surface to keep it away from the mud.
Okay.
And there's a check valve and a filter on that, just so something can't get back into the box.
Okay.
Those valves have to breathe when they cycle.
Okay.
Everything was designed for 10-meter depth, the boxes.
Okay.
Now, this is really important. To deploy this, the first thing you want to do is fill these tanks completely full.
Completely full. Okay.
Because if this is unloaded, to put it in the water right now, like it is now with no payload, to get it below surface, you'll need to fill those with water.
Yeah.
That weight overcomes the ballast of the air tank.
Yeah.
Once you get it below the surface, then you just tell it to equal itself, and it will bring itself to surface
And you do that from the control interface.
from the control interface.
Right. Okay.
But if you try and deploy it with not enough water in these tanks, and you tell it to
That's
flood
what I was
tanks,
talking about.
I see what you mean.
if you tell it to flood tanks,
Yeah.
it's going to flood all it can, and then that big air tank's going to keep me floating like a buoy. So you got to overcome the weight of that buoyancy by
Right.
filling those with water.
Yeah. That makes sense.
You might could do that with a payload,
Yeah.
because the more payload you put on it, the more pressure it's going to push water in. But
We had about 3,000 pounds on
Yeah.
it that last test, and it still
yeah, it
was
takes
a challenge.
It was.
Yeah, it just took a long time to get it to neutral.
What were you using?
Big
big steel beam.
big
Cages.
12-inch steel beams, just
Oh, you put
laced
okay,
across
yeah.
the top.
Yeah. Yeah.
And trying to put weight on it to get it to submerge like that is not the best idea, because you got to get them completely balanced, or else you'll make the thing.
Oh yeah.
Because once this thing's in the water, it doesn't take a half a gallon of water to make it tilt.
Oh, that's sensitive.
Once it's
Once it's
equalized, yeah.
equalized.
Yeah.
Yeah.
Very little
So
water
it's
change. Is
Very
gonna-
sensitive.
Now that's in a calm sea state.
Yeah. Right.
That if it's in the water, just think about it. If they're all balanced and very
Yeah.
little water change,
Right.
you'll see a tilt. So,
And it'll self-correct.
and it self-correct itself. But if you start putting weight on here, so I'm gonna make it go down, you're gonna be within a quarter inch trying to get that stuff
Yeah.
equally balanced, and it's just too cumbersome.
And that would be a real pain on a day where the water's really choppy.
Yeah.
Trying to
Of
make
course.
it go down.
Right. Yeah.
First initial plunge. I mean, you want to
Yeah.
put your payload may make it work great.
Okay.
There's also for the air charge tank, the supply tank,
I see it there.
where
Yep.
it comes into the control box. When we go to the other side to see it, there's a filter there, an air filter that'll keep debris out of the manifolds for the pneumatic valves. So inside of this control box is two regulators. So when the air supply line comes in, it sees a manifold with two regulators. One regulator is set for 90 psi, that's to operate the pneumatic valves. The other regulator is for the charge tanks, and it's set for 45 because we don't want to put high pressure overcharging these tanks too rapidly, because you could exceed their pressure.
Exactly. They can blow.
So
Well, you got a check valve.
we have a check valve,
Right.
but it's set for 45 because that way you won't overpressure that tank,
Yep.
because the tank's rated for 150.
Okay.
But we want to keep it big safety factor.
So when was the last time you had a last trial you had?
A year ago, maybe a little over. Maybe almost 2 years. Yeah.
Okay.
That's a Wi-Fi antenna inside. It's all encapsulated. It's waterproof. And we walked around with it. It has like a mile range.
I was going to ask you what the range was.
About a mile.
Okay.
And that buoy, if I recall correctly, they said they wanted to pull that buoy below surface in the
In the
wintertime.
wintertime, yeah, they're gonna.
It'd take a few $100 to pull that buoy.
What's it made out of?
It's I think the material is, it's not HDPE. It's a type of polyethylene. But what they do is take a sheet and they heat it and they roll it on a lathe.
Oh yeah,
And
yeah.
it's roll and roll and roll.
Right.
Then the outside is just smeared over to make the skin. It's very
Oh,
You can
okay.
get that with a boat, I heard.
That's the same type of material they used with when they were making those submersible divers, deep sea divers. They had used some sort of a polyethylene that they wrapped it in layers, and they would be able to withstand up to like 11,000 feet pressure.
Yeah.
11,000. I seen a documentary about it. It was really, I thought that was really interesting. Okay.
I think the manufacturer of that material was Gilman.
Yeah.
I think it's,
Okay.
this frame was designed to carry the payload on it was around 6,000 pounds.
Okay.
We have a note somewhere that told how many bags it was.
Yeah. Okay. I want to stop.